Okay, these are our notes for section 12.7 on different ways to represent data, on data representations. Now, our notes are going to focus on 4 main ways. There are more ways to represent data, but we're going to focus on 4. We're going to focus on histogram, stem and leaf plot, frequency table, and box and whisker. And each one of these ties to one of our measures of central tendency. If we want to represent, say, mean, for example, one of these 4 ways is going to be the best way to represent mean, and that's important. Another one's going to be the best for mode, another one will be the best for median, one will be good for range, so that you can see all of that stuff right off the bat as you're looking at the data representation. We're going to start with a histogram. And all a histogram really is a bar graph. It's not any regular bar graph, though, because most of the time a histogram is a bar graph with intervals. It'll have a spread of values. Say you're looking at the ages of people running a marathon. Well, it'll have a bar for people from 0 to 10, or people from 10 to 20, so that it includes several different ages as it's going through the bar graph. It's not just a specific number. Same thing for an IQ test. Your IQ may be the spread of from 100 to 110 or 110 to 115. It needs to be consistent, the intervals you're using, but a lot of times a histogram will use intervals. A bar graph, though, a regular bar graph, is still a histogram. Okay? Now, if you have a bar graph that looks like this, that's called, or that general shape, that's the normal distribution. It's also called a bell curve. And if you have a normal distribution, that means you have a very good data set. It is maximized at the mean. The mean should be the highest point, the average, which tells us that a histogram is very good for finding the average of things. That's the one that it best pairs with. Now, if for some reason we don't have a bell curve, notice that a bell curve mine isn't the way that I drew it, but it should be symmetrical on both sides. It should rise up to the mean the same rate it should fall from the mean. If that doesn't happen, we could have a bunch of values at the beginning, which is a positively skewed graph. It flattens to the right. Or another way of thinking about it is that all of our data is clustered, the big chunk of it, the mean, is to the left. So that the right-hand side is longer. It's got more values on it, and it falls at a lower rate, slower rate. That's what makes it positively skewed. The right-hand side is falling at a slower rate. We could also have a negatively skewed, which is just the opposite. Okay, it flattens to the left, which would mean that on the left-hand side it is climbing at a slower rate, and then it dramatically falls off to the right-hand side. For both of those, the mean isn't in the middle. The mean is either to the left or to the right. You have a mean lower on the lower end of your values, or a mean at the higher end of your values. And those can be tricky for some people. They get confused. What you need to remember, though, is that positively skewed, the right-hand side of the graph is larger. On a negatively skewed, the left-hand side of the graph is larger. And what I mean by larger is that it flattens out to that side, it declines, or it increases at a slower rate than the other side. And again, that's what a histogram would be. Now, a couple characteristics of a histogram, and this all goes in the normal distribution, is that the mean, the median, and the mode are all close, which would mean it'd be a good data set. If you have a positively or negatively skewed, you wouldn't have a good data set. The mean isn't in the middle of your data set like it would be for a normal distribution. Okay? Now, the next thing we're going to look at is a stem and leaf plot. A stem and leaf plot is good for finding the range, because it's very easy to see your highest and your lowest value. It is also good helpful to see your mode. And you can use it for the median. Those are helpful. They're not the best, but it's easy to see those based off of this. Range is the best. Mode is also helpful. Now for a stem and leaf plot, what you do is you have stems on the left and leaves on the right. And you represent numbers. Say we have the number 30. You would represent it as 3, 0. And then if we had the number 31, we already have our 3, and then we put a 1. If we have a repeat, we put another 1. And those would be our leaves. The stem is the tens place, and the leaves is the ones. Now let's say we had 40, 42. We'd put that here. Same thing, 45. We already have the stem, so we just add the leaf. We do include repeats. It needs to be in numerical order. And you need to have a key. And what the key tells you is that suppose we had 3, the line, and 0, we need to say that 3 line 0 equals 30. The reason we do that is because we may have our stem be our hundreds place if our values are really large, or our thousands place. So we keep that, we use the key to tell us that what the numbers should equal. If the 3 line 0 may equal 3,000 or 3 million or whatever it needs to be, depending on what our leaves are. So it's important that you have the key. It's also important you do these two things. You include repeats, and it's in numerical order. Now, it's the best for range because suppose we had 99. Right off the bat, I can see the highest and the lowest value. They're set out very straightforward for us to see. So you can find the highest, find the lowest, and subtract them. It's also good for mode because you can see which values occur most often. In your 30s, notice that there are 2 ones, so they repeat. It's easy to see that represented in this way. And that's what a stem and leaf plot is. And again, it's good for range and also mode. It can help with median, but it's not the best for median. A frequency table is good for mode because, like it says in its name, frequency, it's going to tell you how often something occurs, which is what mode is. It's going to tell you just by looking at it which one happens the most. And there are 2 ways to represent a frequency table. You could literally have a table like this where we have scores or whatever our data set is, and then how often they occur, the frequency of them. So according to this table, the score of 100 occurred 3 times. The score of a 95 occurred twice. The score of a 91 occurred 1 time. So just by looking, you could tell which one the mode is, the one that occurs the most. So in this case, our mode is 86. Now, one thing to be careful of is that if you're finding the mean or the median off of a frequency table, you need to make sure you include those numbers, how often the frequency tells you. So if you had 100, if we were going to find the mean, the average, it'd be 100 plus 100 plus 100 plus 95 plus 95 plus 91. You have to make sure that you're including it that number of times. And if you're going to find the median, you really need to be careful because it may not fall in the value where the mode is. It might, which means it's a good data set if all of those fall in the same place. But just because it's in the middle in the chart, the frequency may throw it off a little bit, and it may fall into a different category. So you can't just go off the scores. You have to include however many the frequency tells you to also. Now, another way to write a frequency table is to make like a histogram, make a bar graph. And I'm going to make a very basic one here with our values. Listing out the values from our table to the left. 87, I don't think I'm going to get them all. 91. We'll go from 70 to 91. Now, another way to show a frequency table is to mark how often these occur. Well, 70 occurred once, so it has 1x. 81 occurred 3 times, so it has 3 x's. 82 occurred twice. 86 occurred 4 times. 87 once. 91 once. If you're looking at a table like this, it will tell you what the frequency is, how often it occurred, and this also helps you see if it's a normal distribution. You can tell whether it looks like a bell curve or not, or if it's positively skewed or negatively skewed. That helps when you write a frequency table out like this. So a frequency table can also help you figure out the distribution. But it is the best for mode, because right off the bat you can tell by looking how often something occurs. Okay, we have one other data representation to look at, and if you've gone through them, histogram was the best for mean, stem and leaf was the best for range, frequency table was the best for mode. That means the stem and leaf is the box and whisker is going to be the best for median. Now there are several steps to finding a box and whisker, and we're going to go through those. I'm not going to give you an example, but I'll go through the steps problem as we go. Okay, step 1 is to get a number line to include all of the data set. A couple things about your number line. It has to include everything, and it must be constant intervals. Notice the one I've written above counts by tens. That's fine. It can count by whatever you want it to. If you want to count by ones, you want to count by fives, it doesn't matter, as long as it includes all of your values. And this includes outliers. Outliers will be important for this one. Okay, it has to include every value. Step 2 is to find the median of the data. Find the middle number, and you're going to mark it. Now, I'm going to make this up as we go. We're going to say that our median value is, let's say, like 32. So it's in between 30 and 40 because I'm counting by tens, but it's closer to the 30. You mark it with a line. Now, what this does is it divides your set into an upper and lower quartile. Okay, you have an upper half of your data and a lower half of your data. And that's what you want. You want 2 parts. Step 3 is then to find the median of one of them. And I usually start with the upper quartile, the upper set of the data. And let's say that that was about 50. And then we mark it. Step 4 is to find the median of the lower quartile. Let's say it was at 11. So now we have 3 marks. And once we have our 3 marks, we're going to connect them to make a box. That's the box part of the box and whisker. Now, step 6 is going to be your whiskers. And you draw lines to the highest and the lowest values. But you exclude outliers, and that's important. So suppose I had an outlier here at 80. It didn't go with the rest of my data set. I'd put a dot there, but I would only draw a whisker to the next one. Let's say this is at 5. That's how my box and whisker would look. This would be an outlier. Now you may or may not have outliers, so it's something that you need to watch for. Instead of putting dots, we put lines. That is my mistake. Dots are okay, it's not a big deal, but we use dots for the outliers. So that's what your box and whisker would look like. And again, make sure that you don't include the outlier. When you draw the whisker, the outlier gets included in everything up to that last step. It's included in the data set to find the medians, to find everything else, but it's not included when you draw the whiskers. Now, a couple things to remember. Remember we said if your data set doesn't have a specific median, you may have to divide two middle numbers to get a median, and that's okay. And you may have to do it more than once. You may have to do it for the median of the whole data set and then the upper and the lower quartile. That's okay. But you may have to do that. It's something to remember. You are just finding the median of the data, which is something you should be okay with. Pay attention to outliers, though, and that's your box and whisker plot. Alright, those are your notes for section 12.7 on data representations. Make sure that you know all four of them. There are other ways to represent data too. There's a pie chart, several different ways. You could have a line graph, a double bar graph, things like that. But these are the four we want to focus on. And one of each goes with one of your measures of central tendency. The histogram goes with the mean, stem and leaf goes with range, frequency table goes with mode, and box and whisker goes with median. Okay, if you have any questions, bring them to class next time. Otherwise, those are the notes for section 12.7.